friends, welcome back to another video. Today we're going to be diving into Amazon. So what exact questions does Amazon ask you when you are interviewing for a business intelligence engineering position? Now this can expand further into business analyst. Now to preface, these aren't all the questions. These are just the ones that I was just most recently asked in, I would say, the last 6 months or so. So pretty recent questions. They are real. These are ones that they asked me and evaluated me on. A couple of them that I didn't get fully. I'll explain my thought process behind them when I do get to them, but we're gonna dive into these questions and how, if I were to do it again, this is how I would answer them. So the first question is a join question. Now, if you don't know what a SQL join is, feel free to look back at this video. I dive deeper and explain what exactly a join is and how to go about explaining, inner join, left join, full join, right join, all of those things. But this question dives deeper into output. So what exactly is going to be the output for this specific query? So this was literally the tables that I was given. They asked, hey, if you have a table with, first table is going to be with values 1, 1, and null, and then the second table is going to be 1, null, 1. What exactly is going to be the output for each specific join? I don't love these questions because they're not realistic in my opinion. Why would you ever need to know the specific output? Why do you need to calculate that in your brain? It's like the computer is always going to do that for you. So it just doesn't make any sense to me personally. But I get the logic where they just want to see if you have a deeper understanding of joins and what exactly that means. I digress. So the first join that we're going to start with is the inner join. Now, just a reminder, the inner join, we're combining everything all together. So we're going to see what's in common between the both. In this instance, you would say the output is going to be 4 ones. 1, 1, 1, 1. That's it. And then both specific columns as well, because you're inner joining 2 columns together. This one is confusing because in an inner join, you're just seeing what's in common, but you typically negate all of the null values. So this is how they're going to try to trick you, and it's with adding these null values. It just makes it seem complicated and nuanced, and at the same time, they're trying to trick you because these are all the same values too. So you're just like overthinking in your head, like, oh, what's the output going to be? What's the output going to be? In this instance now, in the left join, it's going to be everything, all the 4 values. So it's going to be 1, 1, 1, 1. At the same time, another output is going to be 1 null value at the very bottom. So one thing to note in this example as well is on the left join aspect, you're going to get everything from that first table and then everything in common. So everything in dud1 will be the one. If you switch it, then it'll be everything in this table, table 2. Now, if we go to right join, it's going to be the opposite. But as you can see, the null value is in the middle this time. This is because in this table right here, the null value is also in the middle. So we're going to be connecting those tables together. That's why you get this specific output. Now, for the full join, a little bit more simple. It's just going to be all values across all tables, right? So it's going to be all 4 ones, everything in common, as well as everything in both the left and the right table, which is going to be the 2 null values. This question is just tricky because they're not realistic values. It's just like you really have to use your brain and see what exactly the output would be. Again, not my favorite type of question. This is one that they're going to try to use to trick you. In my opinion, even if you don't answer these right, that doesn't mean you don't understand joins and SQL. This is one of those ridiculous interview questions that aren't realistic. Now, that's that first question. Now we're going to dive into the next one. They're going to show you a specific table with a customer ID and a product column. And then they're going to ask you, how would you get the list of customers who bought all the products in table Y, which is another specific table. This was a question that the recruiter sent me and said this could be an example question. So I made sure to look into it and see what potential answers I could give. So say we have this table Y. I always just start with the basic select from. Let's say we call it table Y. So in this, we're going to assume that there is a customer ID and some sort of customer name as well in this table Y. I'll just call this Y. So Y.customer ID. So we're going to grab that column and then we're going to do a simple group by. It's going to be wondering why are we doing group by? We're trying to gather all the customers who are all of the products in this table. So we need to condense it into this by customer sort of format. So we're going to do a having count. So distinct product is equal to select count distinct product from table Y. Let me explain. In this example, right, table Y has both customer ID and product. We're going to have this one table. It's going to have both values and we're going to try to need a first group by to gather all of these customer IDs. And then at the same time, we need to make sure when we're considering customers who bought all of the products, this will make sure that per customer ID, we're getting a specific count. And then we're going to make sure that that number per customer is matching with the number per of the total amount of products. When they have the same amount, then it'll come out with that customer ID. This is one example of that. I'm sure there's many other ways you can do that, but that's how you would visualize this in your head when you're trying to think about a specific answer that you're trying to go for. Next question. So for this one, I was asked this one during my interview. So this one is a little more complicated. It has, as you can see, multiple tables that they're going to showcase and highlight. But in this one, I will quickly explain the problem. So the trips table holds all taxi trips. Each trip has a unique ID, while client ID and driver ID are both foreign keys to the user ID at the user table. For status, there are 3 types. You can see right here, we have completed, canceled driver, and canceled by client. In this trips table, we have our primary key, which is ID. We have our client ID, our driver ID, and our city ID. And then we have our requested add, so the specific date for each one. Realistically, it would be some sort of time code as well, so it would go deeper into what time of the day in particular. So next, it's the user table. So this is going to hold all of the users. Each user has a unique user ID and role, client, driver, and it's just one or the other. We have a specific band column, and we also have a user ID. What user is going to be corresponding to this value. This question is asking us to write a SQL query to find the cancellation rate of requests made by unbanned users. This is the key right here. Find the cancellation rate of requests made by unbanned users. Both client and the driver must be unbanned, and it's going to be between these 2 specific dates of October 1st and October 3rd. The cancellation rate is computed by dividing the number of cancels by client or the driver of requests made by unbanned users. So they're giving us the formula right. So for the above tables, your SQL query should return the following rows with the cancellation rate being routed to 2 decimal places. Now we get into some actual meat and potatoes of SQL. As always, start with select and from, and then we're going to go to the trips table. So we're going to call trips T. So when I'm thinking about this question, I am visualizing an ERD in my brain. So what's an ERD? It's an entity relationship diagram. It's how tables go about and connect to each other. So in this example, what I'm visualizing is this main trips table. And then when I see all these foreign keys, I'm imagining 3 separate tables connecting on the outside, which is going to be the users, right? So it's client, driver. So knowing that, I'm just going to do my joins now. So we're going to start with join users from the user table. I'm going to call this one C for client. So I'm going to give it some sort of alias on C.users_ID. So that is right here, right? C.user_ID. I normally just do a copy and paste because for simplicity's sake, and then we're going to do equal T.client_ID. And that is from this trips table as well. After this, then I'm going to grab driver ID as well. You join users D on D.users_ID. Again, the same ID is equal to T.drivers. I'll just copy and paste it first. I don't mess up the syntax. I always have spelling errors, so I always try to be careful of that. We have our joins, right? So this is us visualizing this ERD. Now we're going to go into filtering. So this is what the where clause is normally used for. We're going to go into what filters do we need to take note of. So the first one, of course, is for both the driver and the client that they are not banned. In this, we're going to start with, so we gave it the alias C for our clients. We're going to go C.banned. We're going to make sure it equals no. And we're going to do the same thing here for drivers, D.banned equal to no. So this is our first criteria, making sure that they are unbanned users. That's key. Next, another filter is going to be between these 2 specific dates of October 1st, 2013 and October 3rd, 2013. The entire data set is only that, but just in general, having these sort of filters will also limit the amount of data we're having. Very good, a very realistic way to go about all of this. This will make our data set more efficient in the end. So we're going to go into T.request at, we're going to say it's between, and then I'm going to actually copy and paste these specific dates because I want to make sure it's in their syntax. These are like little things to note when you are coding, just to make sure that they know you are detail oriented. Quickly just copy and paste whatever data it is. So next we're going to go through our select column and quickly do our calculations and select our columns. So what's great about this is that they gave us an output. So what exactly is output going to look like? So this portion right here is going to be our data set. That's how I like to visualize it, right? Like here we are creating our data set. Now we are picking the exact columns we need to give our output. So this is going to be this column, which is request. So we're going to do T.request add, and then we're going to label it because it's labeled here as day. We're going to also do the same thing, just call it today. The next portion here is where we're going to be doing our calculations. They explain it right here, which is the cancellation rate is computed by dividing the number of canceled by client or driver requests made by unbanned users by the total number of requests made by unbanned users. So this is why we have the filter of banned. We need that filter. We're going to just do a simple just count for both. We're going to do a count of T.status, which is right here. And as you can see, we have canceled by driver and canceled by client. We don't really care exactly who canceled what, if we're just caring about the canceled drive. Since there are only 3, we can pretty much just factor out the 1, which is completed. So what I'm going to do is we're going to count for T.status when it's not completed. So we're going to do that count. So this is counting all of canceled ones. And then now we're just going to do a simple divide by count star, which is going to count everything. in that specific column. Another thing that they asked for was to return the following rows rounded to 2 decimal places. So we're gonna make sure to do that. We're gonna do round, boom, we're gonna round by 2. And this should be our cancellation rate. We're gonna call this exactly what it's called here. And then after this, we're going to do a group by. And from here, we need to do a t.request set. So why are we doing a group by? We're doing this because we are getting the calculations by the specific day. And when we do some sort of aggregation, we always need to have a group by in SQL. Always, always, always. I also add an order by to make sure it is ordering by these specific dates. And this is how I would go about answering this SQL question. This one was I believe the second to last one, or my last question in the interview. But this one really goes into the nitty-gritty of SQL and what exactly you need to know when it comes to analyzing a data set and kind of how your brain works in terms of joining tables together. This is the next question that I'm going to go into. The employee table holds all employees. Every employee has an ID, and there's also a column for the department ID. We have the employee table. We have values ID, name, salary, and department ID. Right at the end here, we have the department table, which holds all of the departments per company. The question for the specific data set is going to be write a SQL query to find employees who earn the top 3 salaries in each specific department. That is the key here, in each department. My first initial reaction when I looked at this question was to do a simple top 3. But as I got further into the interview, I had the interviewee help me a little bit, and he corrected me where I forgot to answer the specific part of it, which is in each of the department. So when you see that sort of statement, that always means you're going to be working with ranking functions. Now, when you're working with ranking functions, you always need to be using a CTE, which is a common table expression. There's a form of a subquery. It's a subquery that is pretty popular. It depends on if that's the way your brain works, but in this specific example, you need to use a CTE. We're going to first start off with the key statements of with CTE 1, and then we're going to label it as boom. This is sort of the basic framework for what a CTE is going to look like. Again, this is a subquery, right? So we're going to have a specific query at the very top, and then we're going to reference it at the very bottom. So let's quickly do that right now. We're going to do a select from. So we need to find the employees that earn the top 3 salaries in each department. So what we're going to do here is grab everything from the employees table, which is right here. So I'm going to call it employee. Select from employee, and then give it an alias E just to make things easier. And then we're going to do a simple join, an inner join on department, which is going to be this table right here. Call it D, and we'll do on d.id is equal to e.id. So we're connecting both tables off of this ID value, department and ID. Boom. You're going to need to get the department name. So d.name, and then I'm going to label this as department name. And then we also need e.name, which is going to be employee name. So we're going to separate these two out, and then at the same time, we're going to need salary, e.salary. So from here, then we also need to do a group by. And why do we need to do a group by? Again, we're doing some sort of aggregation. When we're doing ranking functions, it's always some sort of aggregation. So we're going to put all 3 of those values there. And then from here, we are going to do a dense rank. Now you might be asking, what is a dense rank? So the best way that I would describe it is that in dense rank, the ties matter. So as you can see, we got 1, 2, 2, 3. So they matter. You're not skipping any values. In just rank, you are skipping values. So the tie values, so values that are the same, they do not matter. You don't care about them. But in this case, we care about the first, second, and the third values. Even if there are ties, we need to know who they are. We're not trying to just find 3, the only 3. We're trying to find the top 3. In this instance, we use dense rank, and then the syntax behind this is going to be over, and then we're going to do a partition by d.name, and then we're going to order by e.salary, and then descent. And we're going to call this as rank employee. Boom. So in this instance, we have our query right here. It's going to be partitioning, so it's going to be giving a value to each specific name, which is the department, and going to give it a value based off of the salary. So 1, 2, and 3, or more. It's just going to rank it all, right? It's ranking each value. From here, we're going to do a simple rank employee, which is less than and equal to 3. So what is this doing? Let me explain. We are grabbing everything in this table, right? This whole value, we're ranking everything from the outside. We are grabbing this entire query, so this subquery, a query inside a query. So we're grabbing this query, and then we're doing another filtering on top of it. Now, this is important because you cannot do this when you're doing just one query. It doesn't work like that. You need to have it in 2 separate ones to make sure you have all the data first, and then you do the filtering. That's the key part about subqueries, and most importantly, ranking functions. That is very, very important, and a very important concept to understand. Ranking functions will always need to use a CTE, always, especially when you're doing some sort of filtering afterwards. especially that. That's about 4 questions. Let's do one more. Why not? This is also another one of these just weird join questions. I don't particularly love these ones, but who cares about my opinion? This is what they're gonna ask, right? So if I have a table with follower and followee, where the follower follows the followee, how do I return a table of mutual follows? It's stupid. It's bullshit. With the wording, they're just trying to confuse you. Like, that's what sucks by Amazon, is like they really are trying to confuse you. So you have a table with follower, table with followee, where the follower follows the followee. So where the follower right here follows the followee. How do I return a table of mutual follows? We're going to, of course, start off with our select from, and then we're gonna need to have a where, and then some sort of join. So there is this table, right? We're gonna call it the follows table. We'll call it follows, and then we'll do F1. This is one of those questions where it requires a self join. I have mixed feelings about self joins because you really don't you don't use it that often. In my opinion, SQL was not meant to be used using self joins. If you're using a self join, then something's wrong with your data set, and that's the issue. Your data set was not loaded correctly. This goes back to ETL, working on building your data set using the ETL process, but I digress. So we're gonna join on the same table, but we're gonna call it F2, and then we're gonna join on F1 dot follower is equal to F2 dot followee. So we care about specifically where there are mutual follows, right? Where they're both following each other. Oh, it's a bad feeling when your homie doesn't follow you back. I've had that happen to me a plethora of times. So we have F1 follower and F2 followee. Now we're also going to do an and here. We're going to join on F1 dot followee is equal to F2 dot follow. This is gonna grab those mutual followings, and then at the same time we only want less than F1 dot follow. So we do that again just for extra filtering as well, to make sure that we only get our specific ones we want. We do F1 dot follower as, we'll call this mutual follower. We do F1 dot follow e as mutual underscore follow, and boom. This is how I would go about answering this question. God, self joins are so they're complex for no reason. Oh my God, it's so stupid. It just hurts your brain when it doesn't need to hurt your brain. If they just had 2 separate tables with followers and followees, it would be easier. Why does that have to be in one table? Ugh, it's so dumb. You know what? Let's throw in one more for the shits and giggles. Why not? We'll go through 6 questions then. This one is a very common thing we do actually with data, and it's how can we transform a table using SQL? So changing rows to columns or vice versa. And how can we return from a table like the one below? There are 2 specific ways to note when you are doing this. So there's pivoting and then there's unpivoting. So when you pivot, you are going to be changing things from rows to columns. In this instance, we're going to be using case statements. So here's a basic formula which you can use when you are making these queries. So say we have a customer and product table. I'll give an example right here. Say we have this table and we want to now pivot it. So we're going to go through and grab first, so select product, and then we're going to do a sum in case when customer ID is equal to 1, then 1, else 0, end as customer underscore 1. Boom. So pretty much we're going to be doing this every single time to switch our rows to columns. So customer ID equals 2 from, and then we're going to call just your table name, whatever, and then we'll do group by, and then we'll do product. So this is a basic way to do a simple pivot, and it's going to be using case statements. So it's going to go row by row. If the ID is this, then it's going to flip now, and you're going to pivot your data set. It's hard to explain. Pivoting is complicated, but you need to know how to do this. Now for unpivoting, it's going to be this keyword union all. So from here, we're going to select now our data set that's pivoted, and we want to pivot it back. We're going to customer underscore ID. I'm going to grab product A as product from, we're going to grab your table name, whatever it's, and then where product A is equal to 1. We're going to go through each specific column, make sure that we're grabbing all of that data, and then we're going to do a simple union all. And then again, we're going to select customer ID, product B as product from, same thing, your table name, where product B is equal to 1. And you get the drill. So we're gonna do one more for product C as well. What's key with unions, like I said in my SQL joins video, is that you need to have the same columns in every single query, or this is not going to work. This is probably the most important part about it. As you can see, we have our product, and then we have our customer. We're gonna grab a customer ID per product, and we're gonna smack them all together. Just like that. Wow, I feel like I just went through a whole lecture. That's crazy. That is everything that I went through personally when I went through my most recent Amazon interview for a business intelligence analyst role or engineering role or business analyst role, anything along those lines. This is how I would go about questions like these. I guarantee you're going to be asked one of these weird join questions. So whether it be this one with the 1-1 null value question or this other one where we dive deeper into follower and followee, I would say consistently all of these questions for myself have shown up in nearly every single one of my interviews. I've gotten this follower followee one actually a couple times, and same with this left join right join output, understanding the output question a lot too. So with that being said, I hope that this was helpful for you. I hope that you're able to learn something and apply this to your next interview when it comes to interviewing with Amazon. Make sure to like, follow, and subscribe. It makes a big difference, guys. Also, I'll be putting this entire script, so everything from the create tables to the inserts to all the questions and answers and things like that, I'll put it in the description down below if you want to review that for yourself. I'll catch you guys in the next video. If you guys have any other topics you would like me to go through, any more questions you want me to answer, feel free to let me know and I'll make that into another video as well. I'll catch you guys next one. Peace. Ooh.